Hello, this is Operating Systems 471, and I am making a video to get you started with homework 3. I put everything into this file. So now I have a order for you to work on things. I'm going to follow along here in my test account. Okay, I will get rid of this. All right, so first of all, these commands here are to get you my version of xv6, and you want to do this again because I just updated those files recently. So cd to my home directory, make a directory to put this stuff in. Then I'm going to copy over the code from, right, I'm in this directory here, and I copied over, and these are all the .o files. Those are the compiled files, and also the file system images. Actually, probably all you really need is the file system images. And then the make file is set so that you can still run qemu. So this is now running my version of xv6. It has some extra, it might have some extra programs in there that yours doesn't. Importantly, it has free, so you can run my version of free to see what it prints. There's a usage statement. So these are the options that my version of free can handle. So free-t, and what I say here is you want to run this, and you want to pay attention to what it's printing and consult back with the chapter 2 in the xv6 textbook if needed to understand what this stuff means. All right, and that's also in the previous video. Okay, so step 1 is just getting my stuff, making sure you can run it, making sure you understand what it's printing. All right, after you do that, then it's time to make your system call, page dir dump. So you're going to go over to your version of the, right, your directory where you have all your files, right, that you're editing, and go ahead and make your new page dir dump. And initially, just have it print, right? So you put the new system call in, you modify the files that need to be modified to make a new system call. Make it so your free.c from 3a, modify that so it's going to call page dir dump, and just leave page dir dump empty to start with and just have it print hello. So you should be able to run your, right, you want to run your free. I don't think there's a free in this directory right here. So you want to run your free, and it should call page dir dump, and you should see just a printout. And I'll actually update this README. So here, yes, it's there. Use the cprintf. Okay, so that'll work from your system call. And you either modify your free.c, or you could copy my free.c, which you do have in this other account, in this other directory. So in there is a free.c. which is the starting point for your homework 3B. What's in here is mostly the code that you need for 3B. So there's a global variable, there's some flags here, there's a usage statement. This parses the flags. You want to look at this and understand what it's doing. You can put your homework 3A code in there. And then there's some more variables, potentially for doing the pointer stuff. And then there's a call to page_dir_dump. And page_dir_dump is supposed to take a pointer and a flags variable, flags from integer. Okay, so you can take mine and use it, or you can modify yours to put this in here. And you're going to want eventually to have these options parsed, and you can do that yourself, or you can take it from my code. Okay, so that's your second step. Third step, so this is basically going to be working through just a little bit at a time. For the third step, I want you to, in your page_dir_dump, get the parameters. And that will be similar to getting the parameters from homework 3A system, whatever it was. The system call from homework 3A. There's parameters for that one as well. Okay, and then for the main part of the assignment, you want to start working either on -T or -P in your version of the program, right over here in your directory. You want to be running mine from this directory to know what you're supposed to print, and then work on it one step at a time. I put some things here that you will pretty much need to do this stuff in either case, for -T and for -P. All right, so you want to look through that. Whichever you're going to work on, the -T or the -P first, consult back to this for how to do some of this. And then these are 3 files that have stuff you're going to want to use. In particular, mmu.h, the parts about virtual memory. So here is talking about virtual memory, some macros that you can use. These are where the flags are in the page table entries and page directory entries. And then this part here. Mem layout has the definitions of kern base, phystop, dev space, and ext mem that are needed in one of the parts. And then you have the physical to virtual, which is needed as well. And then proc.h, what you want out of there is you will need to remember what's the inside of the proc structure. You'll need to use this to get the address of the page directory. One of the parts asks for the k-stack eventually. Okay, and then go through either, so 4A is you're starting with the -T option, 4B is you're starting with the -P option. You'll do both eventually, but whichever one you pick, start working through. This is a reasonable order to get things working. And in the end, you want your output to very closely match mine. And you can run mine to make sure. You'll first start just getting things working reasonably, and then once you think you have the right values everywhere, you can try to make the formatting look pretty close. A sanity check on the -P. I'll put that in here as well. For the -P part, the value printed in the end from page_dir_dump should match what free.c prints. So the free.c, eventually, when you have it all working, it prints the value at the address, right? This is a memory address, that's a pointer. At that location, there's a value 5a. In the end, the page dump finds that value by tracing through the page directory in the page table. It should be the same. If it's not the same, then you have a problem. Okay, so that's a sanity check for the -p, and the sanity check for the -t would be that you should get similar values to mine. Probably you're going to get one page directory entry in the user virtual memory, half of the virtual memory. You should get one there. You should get the same number here. There's an off by one issue there. We'll just kind of leave that. All right, so that's the assignment. Good luck.